Hi everyone, welcome back to the channel. Today we are going to dive into an exciting project that blends flexible PCB technology with neodymium magnet. Inspired by Carl Bujega's Flexa, we are going to explore how these flexible PCB actuators work, their design, their implementation, and their potential application in different technological domains. Big shout out to PCBWay for sponsoring this project. More about them later. What exactly are these flexible PCB actuators? Flexible PCBs, unlike their rigid counterparts, are made from flexible materials like polyamide that allows them to bend and flex without breaking. This flexibility opens up a range of innovative applications that the rigid PCBs just can't handle. Let's dive right into the design and implementation of these actuators. Our design starts with a circular spiral inductor and a straight arm for connectivity. The flex PCB is paired with neodymium magnets for actuation. To prevent tearing at the junction between the coil and the arm, we implemented a curved shape and set the arm length to 5 mm. Let's talk about the fabrication and testing process. I send the designs to PCBWay for manufacturing. PCBWay ensures our PCBs are fabricated flawlessly. They provide high-quality printed circuit boards at unbeatable prices. Look no further than PCBWay, your one-stop solution for all your PCB needs. We take quality seriously. The PCBs I got are of excellent quality, and you see, these are of just 0.1 mm thickness. They also have really good customer service. They asked me some engineering questions, and like the wire I made for the coil wasn't actually at the center, and they made sure that it wasn't a mistake. My initial design for the driver board included a 555 timer for signal delivery, a 12-volt power supply, and an S9013 transistor. When I tried to drive more than 2 coils, the S9013 would always blow off. Then I tested and calculated the current draw, and it was found that initially it drew around 400 mA per coil, which was too high and it would get really hot. To fix this, I used a 100 ohm resistor to limit the current to around 80 mA per coil, and also replaced the S9013 with a KIP122 Darlington transistor for its higher current handling capacity, around 5 ampere for collector current. I used foam sheet to make it into the mirror array arrangement, and it also gives stability, and I have drilled tiny holes to pass the wires through it. I'm using this reflective material that I actually got from the back of LCD screens of phone to represent the mirrors. These flexible PCB actuators have a wide range of applications. Let's go through some of the most exciting ones. These actuators can be used in setups like mirror array systems, which can be useful in adaptive optics and laser beam steering, where light needed to be directed to a particular places. It works by using electromagnetic principles. I pass current through the coil and have neodymium magnets under it which the coil attract or repel depending on the direction of the current flow and poles of the magnet. It can also be integrated with microcontroller, for example like an Arduino, to control them individually. Here I am just running the normal Knight Rider sketch to show it in action. Hear the sound it produces when striking the magnets, like the music created using the relays. The angle of actuation can be varied by varying the PWM signal. Instead of actuating the flexible PCB itself, it can actuate the magnets, like it can be used to slide the magnets. It will also work as a speaker. I found it accidentally. It can directly work by changing the PWM pulses from an Arduino. I have used the common Arduino pictures library to create this talk. But in order to make the sound amplify, I just used a transistor to supply 9 volt. Yeah, it's too high. Also depends on the material on which it is placed. It actually works like a normal speaker by pushing the air around, but doesn't have a chamber and all, but works on the surface. It can be used in wireless transmission of power, not much, but enough to drive an LED. I used the ESP32's DAC to get a much more smooth sine wave and tried with different frequencies. All the codes related to this project is shared in my GitHub. It is a butterfly if you want it to be. artistic installations like this can also be done. Here are some details about flexible PCB and its electrical parameters. Not sure if the magnetic field strength is correct since I used the phone sensor to measure it. I used KiCad for designing these flexible PCBs because in KiCad you have much more tools to make designs. Like for example, this coils was made using a KiCad plugin. Looking ahead, there are several improvements that I'm considering to enhance these actuators, like increasing the number of turns in the coil, increasing the layers, and adding stiffeners to the arm. And one of the critical mistakes that I made was making the pad size really small. So in the next iteration, maybe I will rectify the problem. That's a wrap. I hope you found this project as exciting as I did, and once again a huge thanks to PCB for making this project possible. And if you like the video, give it a thumbs up and subscribe to this channel. Thanks for watching. I'll see you next time.